Hi, we are Team iSEDE. Our main objective is to disaggregate the electronics of a nano-satellite across an all-inflatable structure. This structure will then be tested on a high-altitude balloon flight in September 2013 as part of the European Space Agency's BEXUS scheme. This project is intended to be a proof of concept, and we envisage that it will be a technology enabler for the future and will allow for the design and deployment of multipurpose shape-altering inflatable satellites. During the BEXUS flight, 2 iSEDE satellites shall be deployed from a stowed configuration at the balloon's float altitude. The smart structure will then actuate a number of times. Measurements will be taken to gather data about its performance. Ground support software being developed will also allow real-time monitoring of the iSEDE experiment and provide an interface to control the operation of the satellite throughout flight.
The actuation of the iSEDE inflatable is inspired by nature's heliotropism, where motor cells in the plant stem change the pressure in between neighboring cells, flexing the stem of the plant. By mimicking this principle with micropumps and soft robotic actuators, which are manufactured out of silicon rubber, the iSEDE inflatable obtains the capability of changing its globe shape.
Disaggregation of the electronics is a key objective for this project. This assists in removing the dense mechanical structure seen in conventional satellite design. Electrical design must enable communication with other experiment components, control the actuation of the smart structure, perform vital measurements, and facilitate distribution of power across the full structure. The power architecture has been designed to simulate the charging and discharging of batteries that would occur if the satellite was orbiting the Earth.
Mechanical design encompasses integration of the experiment with the BEXUS gondola, the development of a deployment mechanism, and specification of the inflatable structure. The processes used are defined by the nature of the environment, very low pressures and temperatures. Inflation of the structure, therefore, occurs by trapping small amounts of air within each cell at atmospheric pressure. This air then expands in the vacuum of space. In order to verify the performance of the experiment in a space-like environment prior to launch, individual elements will undergo thermal and vacuum testing. This will minimise the risk of an equipment malfunction during flight.
The iSEDE project has required a large team with a wide variety of skills. Students have been brought together from electrical, mechanical and software engineering disciplines, from undergraduate BEng to PhD level. Following selection for the BEXUS programme in December, regular full team meetings have been held to carefully monitor progress. This has led to a successful preliminary design review and will ensure that the project stays on track. The team is now preparing for the critical design review with ESA and is looking forward to the launch campaign later this year.